Students, the next topic is motion of freely falling body. Motion of freely falling body. In this topic, before that, let us see one small activity to learn this topic. See here, free fall. Now let us see the definition of free fall. Any object that is being acted upon only by the force of gravity is said to be in the state of free fall. For example, for free fall, we can say that lift. In the lift, there is no wire connection. Lift is in problem. We are at upstairs. Without any wire connection, it is coming straight down. It is a free fall. Okay, va? So, any object that is being acted upon only by the force of gravity is said to be in the state of free fall. Gravity or force, one object is coming down or one object is acting means it is said to be as free fall. So here the initial velocity u is equal to 0, acceleration a is equal to g. Acceleration a is equal to g. Now let us do one activity. First we are taking large stone and eraser. One hand we are having large stone and the another one hand we are having eraser. We are throwing both at the ground. ரெண்டையும் வந்து groundல போடுறோம். While at the time both reaches same time on the ground. You take one stone and you take one eraser on the hand. Throw the eraser and throw the stone at the same time. Both reaches the same time on the ground. Next is we are having eraser and paper. One hand we are having eraser and another one hand we are having paper. If we throw both the thing at the down, eraser reaches first on the ground, paper reaches later. If we throw eraser and paper both to the ground, eraser is throwing down and paper is throwing down. Eraser reaches first. This reaches first to the ground. Eraser reaches first on the ground, paper reaches later. Next is we are having paper at one hand. Next is crumbled paper. Crumbled paper means we are taking 2 or 3 papers and we are making as a ball. So we are having paper and a crumbled paper. If we are throwing these two at down means crumbled paper reaches first to the ground. Okay, wow. Let us see why it reaches. Okay. Next is we are having ball one hand and paper on hand. We are throwing both at the ground. Ball reaches the ground first. Paper reaches later. According to the acceleration due to gravity, the objects reaches first to the ground because there is no force, just we are throwing. According to the acceleration of gravity, it is reaching. So while comparing large stone and eraser, both reaches the same time. While we are taking eraser and paper, eraser is reaching first on the ground, paper is reaching later. Next we are taking paper and crumbled paper. At the time crumbled paper is reaching first. Next ball and paper, ball is reaching first. So some of the objects reached first and some of the objects reached later. Let us see the reason. In the absence of air medium, all the objects would have reached the ground at the same time. Because of the absence of air medium is vacuum. Okay, va? Vacuum means without air. Without air medium, that is said to be as vacuum. So in the absence of air medium, all the objects would have reached the ground at the same time. Next is in air medium, air forces some resistance to freely falling body. Paper is of less weight. So air medium, air offers some resistance for freely falling. So it is becoming late. Next is magnitude of air resistance depend on the area of object exposed to air. Magnitude of air resistance depends on the area of objects that is exposed to air. Next is object experiences acceleration during free fall. Object experiences the acceleration while it is free falling, it experiences the acceleration. Next is acceleration is independent of masses. These are the reason why some objects reached first and some objects reached later. Okay, now see here. It can be seen from these activities that the magnitude of air resistance depends on the area of objects that is exposed to air. So we know that the object experiences acceleration during free fall. So this acceleration experienced an object is independent of mass. Next is, this means that all the object hollow or solid, big or small, should fall at the same rate. If an object is hollow or it is a solid, if it is big or small, it all should fall at the same time. So the equation of motion for a freely falling body. We are deriving an equation for free falling body. For this we are taking three equations. What are the three equations? V is equal to u plus at, S is equal to ut plus half at square. Next is v square is equal to u square plus 2as. These are the three equations. By using these three equations, we are getting a equation for motion. Okay, we are substituting u value as 0. Already they had given. Because it is a free fall, so there is no initial velocity, so we are taking u value as 0 and a as g and a as g. See here, substitute u is equal to 0 and a is equal to g in above equation. In first equation we are substituting u is equal to 0 and a is equal to g. So see here, v is equal to 0. What is the first equation? V is equal to u plus at. So for u we are substituting 0 and for a we are substituting g and t. So v is equal to gt. This is another equation. Now while deriving with first equation, we are getting v is equal to gt. Now we are taking second equation. What is the second equation? S is equal to ut plus half at square. This is the second equation. Now for u we are substituting 0 into t plus half. What is the a? G t square. G t square. So see here, s is equal to 0 t is 0 into anything will be 0. So half g t square. This is the value of s. Are you clear? Now we are deriving with third equation. What is our third equation? Third equation is v square is equal to u square plus 2as. This is the third equation. So v square is equal to, what is the u value? 0. 0 square plus 2gs. So v square is equal to 2gs. 0 square பண்ணும்போது we are getting the value 0. So v square is equal to 2gs. Here s is the distance. It is taken as height. So v square is equal to 2g h. Are you clear? This is the equation of motion for freely falling body. See here. Now one question for you. Can a body have zero velocity and finite acceleration? If a body is having zero velocity, whether it can have finite acceleration? Yes. See here. An object is, we are going by this side, and while coming as written, our velocity will be 0. Our velocity will be 0. See here, a is the when we throw an object vertically upwards, it moves against the acceleration due to gravity. So while going upwards, it is against the acceleration due to gravity. So here we are keeping the a value as minus g because the acceleration due to gravity is against. So hence a is taken as minus g. When moving downwards, a is taken as plus g. When moving downwards, a is taken as plus g because while coming down, it is taking the acceleration due to gravity. கீழ வரும்போது it is denoting as acceleration due to gravity. So it is taken as positive. See here a is the finite acceleration and minus g. Minus g is that for upward motion. For upward motion, a is equal to minus g, and for downward motion, a is equal to plus g. Because if we throw an object vertically upwards, it moves against acceleration due to gravity. If we throw downwards, it is relating to acceleration due to gravity. So it is behaving as a is equal to plus g and a is equal to minus g. Are you clear with the topic motion of freely falling body?